welcome to Defender Fridays. Happy Friday, everyone. Hope everyone's having an awesome week. As you all know, this is our weekly get-together with, brilliant folks across the space to have a cool fireside chat around topics that are, well, I say Defender-related, but really ultimately it's just InfoSec as a whole, right? We had an offensive conversation last week that was super cool. We were, talking about all the ways to break LLMs, the advancements in LLMs, and how that can be both beneficial and also add additional risk. So like we kind of focus on all areas, but this week I'm particularly excited because it's a topic that's near and dear to my heart. We're going to get into a little bit of kind of a digital forensics and incident response capability that was introduced by a new tool. This thing is super fresh. Like, Johan, how recently did OpenRelik really hit the tarmac? Because it was maybe a couple of weeks.
Yeah, a couple of weeks for the open source release, and I started hacking on it in March, I think, this year. So it's fairly new.
Oh man, yeah. That is epic. So I'm really thrilled to talk about this. I'm going to let Johan introduce the tool and kind of what it does, but it's an open source tool as well. So that's like another reason why I'm all about hearing about this. But just, by way of brief introduction. So Johan's joining us here. He's a staff engineer at Google. He's actually been involved in several really awesome projects that some of you are probably familiar with. But his latest project, OpenRelik, is the one that's got me most excited because it's something that when it was introduced, I'm like, this solves problems that traditionally we've had to tackle the hard way, and it's open source. So, anyone can kind of hack on it, contribute to it, and that's just kind of awesome news for everybody. But Johan, could you give us a little bit of background, kind of tell us what you're up to, and then definitely give us a breakdown of OpenRelik?
Yeah, sure. So I'm Johan. I do incident response forensics at Google. Been doing that for a while. It's over a decade now at that company. It's been a lot of fun. Before that, I have a sysadmin background, so this is where I came from, right? So doing sysadmin, a lot of open source has always been close to me, coming from the academics and so on, right? So sysadmin, network admin, and then going into security a few years back. So that's kind of me. Been doing open source project for a while, and the newest one is OpenRelik, as you said there, Eric. And I'm happy to present it and I'm happy to talk about that. Yeah.
Oh yeah, no, I know you wanted to maybe show us around the tool itself. Here, I'm going to promote you so you can screen share with us.
Okay, cool. Let's see if I can do this. All right. Cool. Can we see this?
Yes.
All right, awesome. Yeah, so we'll get to that in a little bit. So want to give you a little bit of background on what this is, why I built this in the first place. There's actually a little bit of a backstory around it, where it came from. So I had this idea for kind of a forensic orchestration tool for a long time, and we have been dabbing at that for a while, right? And earlier this year, I was invited by the Swedish Armed Forces. So there was a cyber exercise, one of the largest actually in the world. There's a bunch of folks in that exercise. It's a kind of a classic red team, blue team exercise. It's held by NATO, so it's NATO countries and allies practicing together. It's a lot of fun. But I was invited by the Swedish Armed Forces, and they were organizing and organize the Swedish participation in this, right? So the Swedish and Icelandic collaboration happened. They asked me to help them run and set up the SOC team for our team. So that's where that came from, right? So this was a super fun exercise in itself. And I know, Eric, you're all in on cyber rages and exercises and doing stuff like that. This was cool. Give you just a little bit brief of overview of that one is, you have 2 days of gameplay and just a few days to prepare, like going from scratch to like zero to setting up infrastructure and setting everything up. Fairly large team. So the scenario is that you have a fictitious country, right? So you have a nation and you have a bunch of infrastructure that you need to defend, make sure that they're up and running. And then you get attacked a lot during a 2-day exercise, and you need to keep things up and running. So that means that we have kind of a big team in that exercise, and we needed a way to collaborate. We have experts from Windows, ICS systems, SCADA systems. You have network engineers, you have legal comms, all over there. So and also a forensics team and a SOC team, of course. So we needed a way to organize ourselves and needed a way to share artifacts among each other, right? So the forensics team had more of a CTF type of exercise, where it is CTF competition, I guess. But the artifacts coming out from that were actually used in the larger gameplay, right? So that was important to capture. But then also we needed a way to share these analysis of these artifacts and that stuff with other ops teams. So, Windows teams and networks teams and so on. So we had this gap there, and we didn't have this tool. And I just figured that, hey, let's build. This is a good opportunity to build something fun, have some fun during some late nights, and hack that together and see where it gets to, right? And it turned out to be pretty useful. So that's kind of the backstory of OpenRelik and what is now OpenRelik. It had no name at the time, but that's where it came from. So let's dive in, I guess, and take a look at what OpenRelik is. See if I can. Can you see this architecture overview first?
Indeed.
Yeah, so maybe it's easier to talk about it when I show this. So what I needed, right? There's a bunch of workflow systems out there, and probably stuff that we could try out and use, right? But what I was missing was especially two key high-level design decisions that I didn't kind of find anywhere else. By the way, we had to build this on duct tape and shoestrings, so that's like building it ourselves was easier. So I needed this artifact-centric approach to a forensic workflow orchestration, right? So collaboration was key. We needed to be able to collaborate between teams, and not necessarily only security folks, but also ops teams and others, right? We needed to be able to share our workflows, building these workflows, building them with tools that we are accustomed to. We know them, we can install them and run them, right? But that's not true for everyone. So be able to share these workflows was something that we wanted as well. We also needed and wanted to reason about what have been done to artifacts, right? So if the forensics team have done a bunch of processing on them, analysis on these artifacts, finding some IOCs, whatever, right? We wanted that to bubble up and be communicated to other teams so they can learn and take that to defend, to build detections or whatnot. So that's kind of the artifact-centric approach. So having a central repository of all of the files that you collect in your pipelines, and then process them there and make that visible. And I will show you in a little bit.
Just to make sure I'm understanding this right, to some extent, this happens to be often used for defer incident response and such, but you effectively have, if it's a thing that can be processed with Docker instances and large language models, then this is a way to build out your workflow instead of hard coding it somewhere, making it once. This is the way of automating all of the workflows that could be processed using Docker, essentially.
Absolutely. So it happens to be centered around DFIR because that's where I live, right? That's my world. But you could use it for whatever, actually. And we'll get to that in the architecture here. I will show you how that kind of fits together. Yeah.
Because Jeff, he even publishes like a worker template. And sorry, Johan, you might already be planning to talk about this, but basically like you want to make your own worker that does whatever the thing you want to do. Like, here's a template, build it out. Yeah, it's super cool.
Yeah, that's a great segue, Eric, actually, to the next one. Like the other key design decision that we made here was it needs to be extendable and super easy to extend, right? So we wanted to have a platform where we can, have a stable platform for orchestrating the workflows, running them, having that kind of as an execution environment, and then be able to super easily extend that with new workers. During the exercise, we needed to be able to do that on the spot, right? We had 8 hours of constant attacks. You don't have time to fiddle around, right? But we needed to introduce a new tool or do a new processing. We wanted that to be simple, right? So how we did that, and the design around it is that we wanted to decouple the workers completely from the core system, meaning that they are running separately in Docker containers, and we kind of outsource the maintenance of the workers to whoever built it, right? Meaning, if you want to extend or add new capabilities, meaning you want to add a new tool to your processing workflows, You can build your worker, and as Eric mentioned, we have some templates around that to make it simple, right? You can build that. It's basically a small wrapper around the OpenRelik system. Then you can run whatever you want in that worker in your Docker container. You install your dependencies and so on, right? So yeah, easy to extend the platform with new workers, super important for us. Decoupling them from the core system. And so you can see the architecture here, right? So that's what we wanted to do. The workers are completely decoupled. You don't have to really, we have no dependencies on the core system. You have to confirm to kind of an interface, of course, right? And you have to package them up in a Docker container that is based on this template in order for them to kind of self-register. But if you do that, they will, and you start the Docker container in your Docker Compose, or if you're running that on Kubernetes or whatever, wherever you run it, right? But when that is connected to your system, the only dependency is that you connect to the task queue. And when you do that, it automatically registers to the core system, the platform, and it's available for you in the UI to choose and use as a processing unit, basically, right? So kind of what I'm most excited about is that decoupling in the system, where I hope, and one of the hopes here is that it's going to be easy enough to build these workers so the community can start building them, right? And extend the platform.
Johan, one of the first things I did when I found this project, because one of the things I enjoy to do is like, okay, a new fledgling project that's extendable, right? Let me go teach it my favorite tricks, because like, Hayabusa and things like that. Mm-hmm. And notice Hayabusa wasn't prepackaged. So I was like, oh, an opportunity. But then I went to your GitHub, I'm like, oh, he's already done it. He's already got it in there. Brilliant. That is super exciting. And the way you kind of thought forward ahead, like with the distributed workers, right? That means that I can have completely separate like clusters of Docker containers, right? So I can have relatively low compute persistently, and then on-demand spin up compute when I need to do big processing, and then it just kind of spins back down, and that is just magic.
Definitely, and also another aspect of it is that you can create your own kind of internal workers as well. If you have software that is, I don't know, your internal tools that you're not having open and public, right? You can build your work and run it internally just for you on your OpenRelik server, right? So that's also one of the use cases that we can support with this. And also, as to say there, Eric, you can also then scale out, of course, right? This is, if you need 15 parcel workers to create pipelines, you can just spin them up and then spin them down when you're done. So if you go a little bit, I guess, tech nerdy here, but, in this architecture, super high level, but I guess the magic is in this mediator server, right? So what we did was, it's a very classic distributed worker task queue system, right? For those who have been dabbing in this, it's a familiar architecture stack with Celery and Python workers and whatnot, right? So that's kind of what that is. But what we did was creating this mediator server sitting in between the core system, meaning the API server, the database, and all of that stuff, and the workers. And the workers only communicate via messages. So it's kind of a message passing system here, where they send messages, the mediator server catches those messages and mediates that information back to the backend system, which means that we can have zero dependency on the core system from the workers, which is a nice feature there. And then, of course, we have a shared file system, so you need to kind of provide a shared file system, but NFS file store, I don't know, something on AWS probably works. Like as long as the workers and the core system can access the same files, that you're all good to go. Then of course we have a web UI accessing that. So let's take a look at that now, and some LLM services for those who like that as well.
Real quick before we dive into the web UI, I understand the web UI is simply calling the APIs of the API server. Is the API fairly robust at this point, where there's maybe an SDK, or at least just build your own sort of interface for the API that you could fully sort of autonomously use OpenRelik without even leveraging the web UI?
Yeah, definitely. So that's it's going to be. I have to one. I guess word of caution is that it's going to be a little bit of a roller coaster when it comes to stability in the API and the data models and stuff, because it's a new, very, very fresh project. So it's going to have some changes there. But that being said, yes, we do have the API server is fairly stable in that sense. It's just an open API. Things you can generate your own clients. We do have a very simple API client, Python API client, if you want to use that. Otherwise, just normal HTTP requests is also good. But it's self-documented, and yeah, it should be easy to incorporate that into any other like CLI tools, or if you want to build your own UI, feel free to do that. Actually, one thing that I did, it was not having a monorepo for this. So we have a bunch of different repositories. If you look at the GitHub organization, OpenRelik, you see like 16 repositories or something. But this is because we wanted to separate all of this, the different components here, right? So API server is one, and then you have the UI that just connects to it. They're actually running in different containers, which means that if you want to build your own UI on top of this, feel free to do so. And yeah, so that's that. Let's go in here. You can see the web UI now, right? If I can remember my things.
Which I want to call out, has native support for Google OAuth, which I thought was pretty cool. Like, it was super simple to set that up.
Google OAuth, and I actually added a local authentication now as well. So if you want to do that, so I'm quite happy with the deployment scripts for those who want to test this out. Like if you run the deployment script, which is documented on openrelik.org, and you have Docker installed, it should give you up and running in 30 seconds or so.
I can attest. It was so freaking fast. I couldn't believe it.
All right, so like a cooking show, I guess I prepared a folder for us, but this is the web UI for OpenRelik. It's nothing really groundbreaking here, right? It's files and folders, because you organize your artifacts and files into folders or subfolders and so on and so forth. And when you create workflows, as I will show in a little bit here, that also creates a new workflow folder for the output files and so on and so forth. So that's kind of how you organize stuff. You can be pretty familiar, I guess, with that. But yeah, so it's files and folders. You can create folders, and we can go into one of them. I uploaded a few kind of test files here, but this is where you upload files, or if you have automation, there may or may not be integrations to EDR systems in the future, who knows? But however you fetch your artifact, they end up in a folder. So this is how it looks like. So we have some EVTX files here. We have a Windows disk image, I think it is. So here you can do a bunch of stuff, right? So if you want to take a look at one of these files, you can go into them. This is just the basic properties. Going to probably be more of these, but just some metadata about that file. The content, if you can look at it, you can't hear because it's a disk image. So, but you can download it, of course, and do whatever. So it's kind of a file repository, right? Yep. The interesting part here is the workflows, though. So let's create a workflow out of this. So this is a disk image and a Windows disk image. We want to do a bunch of stuff on it. So I'll create a workflow. We'll create a new workflow. And then you come into this like workflow designer phase, right? Where you can design these workflows. And what is happening here in the backend is that when you're creating and we're clicking around here, it's going to create a specification of a workflow that it is then on the server side, when you execute it, actually translated into a Celery workflow, Canvas workflow, meaning it translates this to Python functions and signatures and so on and so forth. But that's totally transparent for you. You only need to click around in this interface to create these workflows. So let's take a look at this, what we have here. So when you have this data, we can start creating this, right? So say that we want to do, what do we want to do here? We want to create a Plasto timeline. That's usually what you want to do, right? So you do that. So now you have a task that will be processing the input data here, right? For some of them, you can configure them. So in Plasto, you can configure them to just select artifact to parse or some other settings there, right?
Oh, brilliant.
So based on that, so that's going to happen. Based on that, you can then create a p.csv file. So out of the Plasto log file, you will get a CSV file, which is pretty cool, right? But you probably want to push this to TimeSketch as well, right? So when you do that, you can go back in your workflow, create another task here and say that I want to upload the result to this to TimeSketch as well. These will run in parallel, actually, right? So they're independent of each other, but they process the same output file. All right, so that's cool, but let's do more here, right? So what do we have here? This is actually really cool. Extracting artifacts. So we have a artifact extracting task, which means that out of this disk image, I want to extract, say, for example, all Windows event logs, right? The event logs. This is another open source project, by the way, which is Forensic Artifacts. I can drop a link later. But say that we want to extract all of the event logs from this Windows image. I will do that. You will see here, this is another task. Now I can change stuff after this. So based on these extracted events logs, I, again, want to unlock the timeline because it's probably going to be faster, right? We do the same thing here. We do that. We do time sketch. I also want to run Hayabusa because these are event log files, right? Hayabusa is a pretty cool project for triaging event logs and give you some good reports back on that. So let's do that. Let's create a HTML report from it. I also want the CSV report, which happens to be compatible to TimeSketch, and let's upload that to TimeSketch as well, right? So now we have a pretty cool kind of workflow that we can do here, right? So let's just start it. So let's do that. Now we'll see if the demo gods are with us, but now we'll start processing this, right? And you will see that it will be running in parallel, hopefully. Let's see what happens here. So like the timeline is kicking off. The artifact extraction is already done, by the way.
And that's impressive because like you had to mount that EWF in the back end in order to reach in and retrieve those files, right? Okay, got it. That is nuts. That is super freaking cool, man. Yeah.
So now we can see also this is, I do think this is cool. And DeFi are, we are processing a lot of data, and I'm all for triaging and reducing the amount of data that we do and doing phase processing. Yes, Eric, you want to add something there?
Oh, no, I mean, I've got 100 things, but one thing I wanted to ask is that like, so when you build out like a brilliant workflow like this, one that you likely would want to repeat, I see a little save icon as well as a copy icon. Can I like export this workflow as like JSON or some sort of template that I can either, rapidly reapply or share with a colleague, like are those, yeah, okay, I figured as much.
That's exactly what it is, right? So if I, also, by the way, now you can see that our artifact extraction, that worked, right? And that workflow is now done. We have the timelines. The big one is still running because it's taking everything, right? It will take a while to do that. But now we have data to work with. I will get to that, Eric, in the sharing part of it. In just a little bit. But here you can see, like, if you click it, you see the result. These are the extracted EVTX files that task extracted, and you will see them here in that folder, right? So they're just dumped right there for you to do any processing that you need to do on them if you want to. And of course, now all of this kind of finished, right? We take a look at this Hayabusa demo report. So you have that. It created a report for you. You can actually go to it, and with this Hayabusa, we can render them in line as well. So you get the report right there for you to kind of analyze and do whatever you want with. And of course, you can download it and do other stuff there. Hayabusa stuff and the timesketch things. Let's see if that works. So upload to timesketch. What you get there is not files, right? Because you get a link to the sketch that was created. So based on this, we created a sketch for you automatically based on the workflow. And we uploaded the timelines for you, and they should be available for you now.
Johan, a quick question on this. Can OpenRelik be responsible for deploying the TimeSketch instance, or is that kind of still like out of bounds for OpenRelik?
So it is out of scope for OpenRelik. This is you connect your TimeSketch server instance to OpenRelik. So when you have configured that, you can then use it. All right, so this is happening. A bunch of results there already available, right? I want to show you, Eric, the sharing from the features here. So so say that you have a colleague who did an awesome workflow. You want to reuse this, right? And maybe you want to reuse this across investigations. Like this is something we want to do. So maybe you save it, right? So save it as everything, I guess. Everything. We create it as everything. What happens then is that if you go and create a new workflow for something else, you can now choose it here as a template. It will be pre-filled for you, where you can use then, I don't care about this one, I don't care about that one, and you can start remixing it, right? So that's a template that you can reuse in every other investigations that you have. Let's go back to where we were. You can also, if you have someone created a cool workflow and you want to remix it, but on the same data, you hit this copy button. You hit the copy button and it will actually just copy it to your own workflow with an empty output box folder for you, and then you can start remixing it and then run it on your own. So that becomes your workflow based on someone else's workflow, which is pretty cool. This remixing is something that I do think is useful.
Like, okay, so I it's full transparency. So, dug into the tool, I even ran some test images through it, and I thought, this is amazing. But the way that you break this down, the example workflow, like I didn't know we could individually extract artifacts. Like this is insane, man. This is so incredibly good. And like, I'm kind of on the edge of my seat right now. I love this so much.
Yeah, and also integrating this with other systems such as EDRs for collecting artifacts. That's kind of the next step, right? Which would be, you can either do that outside of OpenRelik and just dump them and upload them and sort them here, right? Or we can probably do integrations here as well. But yeah, no, it's the idea is to have a lot of these workers, a lot of these boxes. I'm happy when this box is so big and with so many things that I have to redesign it. With search functionality, but that's a good problem to have later.
Wow. Oh man, that is
How do you look forward to having? Can you speak a little bit to running the? Is there anything that currently works with it via APIs? You could have as I'm thinking like Zeek integrations, as files are pulled off the wire. In some circumstances, automatically submit them to OpenRelik, so you have something going through the same workflow you've already created. What does that pipeline look like?
Yeah, so if you, well, it depends. You can do it both ways, right? Either we do an integration in OpenRelik directly, right? Or you do the other way around when you talk to OpenRelik with API, and you can just push the stuff in there, which is, as long as you have some sort of control over that other software, you can do that. Or you have a middleman there doing that uploading. But yeah, everything is possible.
This is glorious stuff. It's very rarely do I wish, gosh, I wish this were more than a half hour. Quite so hard.
100%, man. 100%. Yeah, this is the thing I think we'd always wanted. When Whitney and I did a talk at the DeFi Summit a couple years ago called Breaches Be Crazy, and it was a much less polished, much more sort of manual way of achieving this level of automation, but not nearly this powerful, right? Like it got the job done. It got you from A to Z, but with a very, very limited sort of, there was no real extendability to it. Like this is everything that was, but now with add-ons and new tools and new features. And I just can't wait to see how this thing grows as adoption picks up, because like, I already know Whit and I we have a plan. We already have an extension idea in mind, and like, an integration that we want to build. I'm gonna save that, but anybody that knows us knows what it's gonna be. But like, I'm stoked. I'm really stoked, man. This is just amazing. So Johan, is it primarily you doing the heavy lifting on this project? Do you have support? How do you feel about the long-term sort of sustainability?
Yeah, that's a great question. For now, it's kind of an experimental system where we are experimenting with a lot of ideas that we have had for a long time, right? And implementing them in this system. And wherever it takes us, we will see. But hopefully we can grow the community around this and stabilize the core system so we can start building, and you have confidence in building workers for this that you can use and easy to maintain. That's kind of the main goal now, is to make that as simple as possible. You mentioned we have the template project already. If you want to build a worker, please let us know. I'm happy to guide and help that as well, for us figuring out how that interface should look like. But yeah, our main goal is to grow the community around this now and see where it goes after.
I think what a brilliant place to deploy something like this, especially for folks running a home lab, is a NAS appliance that supports containers. Because like one of the bigger bottlenecks I imagine here is going to be storage if you're moving big, heavy artifacts. I'm just curious, I guess, where the processing power would then become the next bottleneck. But still, like, I feel like a Synology is like probably where I'm going to deploy it next, just to kind of see how it runs there. But this is just amazing, Johan. I'm so excited.
Yeah, and architecture actually supports, like, you can run it from your laptop. That's everything I did here is just running on my laptop, right? But it's from laptop to a server to just running it on Kubernetes with 100 nodes, right? It's the same type of deployment. You just need to wire it up a little bit differently. But
Oh, that answers a question somebody threw in chat. They said that the performance of your demo was super impressive, and they were curious what the stats on the cluster was. You're running this demo on your laptop right now.
It's yes, it's a MacBook Air. So
Right.
that has a fast hard drive, I guess.
Fair enough.
So everything's been 15 watts or less or whatever.
Exactly. But the nice part is like it's nice to be able to run something locally and then just scale up the same installation into whatever you need it to be, right?
How nice to be able to do that. Yeah. Okay, folks, that brings us to the top of the hour. If I don't shut up now, I probably won't, because this topic is probably one of my favorites. Johan, thank you so much for joining us. I know you had to go through some hurdles in order to get approval to come on, but I really appreciate you doing that, because I've been looking forward to this conversation for a while now. Really, really appreciate it. I hope more folks will go and adopt and submit, thoughts and feedback and use the tool, build new extensions for it. I know that Whitney and I are going to be in there without a doubt. But thank you so much for joining us. Everybody else, have a fantastic rest of your day, and we'll see you. Actually, not next week, because the Lima Charlie Company All Hands will be next week. So I don't know if we're actually hosting it. I'll double check, and then I'll drop something into the Slack channel.
Take care. Thank you for having me. It's a lot of fun.